This illustration covers the requirements for supply-side source connections in accordance with 705.11 D as in dog and E as in Ed. The purpose of change, a new section has been accepted and been added to address supply-side source connection for an electrical power production source. Now, to review the notes that kind of explain this new section, let's review the note 1. And notice note 1 states, when bonding and grounding, see 250.92B as in boy, 700.7B as in boy if it's an emergency system type generator, 701.7B if it's a legally required standby generator, 702.7B as in boy for optional standby type generators. And then also we should deal with 702.11A and B if it's an optional standby generator. But we want to be sure that we classify the generator, as we said many times in this presentation, 700.2 for an emergency, 701.2 for legally required standby generators, and 702 for optional standby generators. And then again, I would like to point out to the user of the 700, 701, and 702 articles to review the article that deals with your design and installation very carefully to make sure that one of the changes in there that we haven't called out for you doesn't affect your design and installation. Now, the notes kind of explain the new section, the purpose of the change. So next, I would just look at the call-outs. It's just for your information. Notice that first, the conductors between the generator and the transfer switch could be, say, number 6 copper or larger by 705.11b when you are using copper conductors. And then notice the power supply from the utility through the meter over to the transfer switch. Then notice these meter connections. We would review 705.11D as in dog and 110.14 for terminations. Now, secondly, the grounded conductor with the arrow showing the grounded conductor routed down to the service equipment with the disconnect. Notice the grounded circuit conductor or legally required standby system connected remotely to the grounding electrode conductor at the service equipment is how this installation is installed. Then notice that we would review 705.7B as in boy and 705.11D as in dog to obtain this information. And notice we're kind of, that grounded conductor in the transfer switch you see there is tied in solidly, and we're not switching the grounded conductor. So that's a maybe a 3-pole transfer switch, as outlined in 250.30, informational notes 1 and 2. So in other words, you could basically say you don't have to ground that generator, because a generator, as you see, is grounded to that grounding electrode system at the service equipment with the disconnect, and it's also really grounded back to the utility also where it's earth grounded. So we find that the grounded conductor is not switched in this case. Now, again, we reference the connections in the transfer switch and the generator. And we look at 705.11D as in dog, but 110.14 would regulate the size of the overcurrent device. And if you're 100 amps or less, your 60 degree C terminals without your equipment is marked 60/75. If you're over 100 amps, then you're automatically 75 C terminals. But we basically stated that you could take the 90-degree rating of the wire and derate it back to a usable 60 or 75, depending on the marking of the terminals, is outlined in 110.14. And the last thing I would like to go over with you in the call-outs is the service equipment with a disconnect. And we want to know how that is regulated and what requirements in what sections would regulate it. And as the first bullet points out, review 705.11c. Why? Well, we review 705 because the service equipment and generator is tied in through the transfer switch, that if we lose power from the utility in any reason, the generator will kick in and supply power to the unit. And then again, you have to classify the generator. And that's in the note 1 above. We've already called that out to you and referenced it so you understand what's taking place here. And then if it's a single main, like you see there in the panel board, which it has to be by 230.71b as in boy, then we would review 230.70b and 230.71b as in boy. And then if you had 2 to 6 disconnects, you would review 230.71, which you're allowed 2 to 6 in individual enclosures. And you could also review 230.72, that which states they have to be grouped. But notice in this panel board, as you see there, then we have to have a main ahead of it. We couldn't have just 6 individual mains in there like the previous code would allow you to maybe have. Now, if you review the note 2 again, just make sure we understand that when connections rated over 1,000 amps or more on Y systems exceed the 150 volts to ground, like 277, and you're rated greater than 1,000 amps on your phases, phase to phase, then ground fault protection would be required at the service by 230.95. Any feeder, your ground fault protection for 277, 480 volt, a 4-wire 3-phase system, we would see 225.10 for a feeder and 210.13 for a branch circuit. Now, notice the branch circuit was included in the 2017 edition. And then if we have more than 6 disconnects, then note 3 says review 230.2A as in Apple 5, along with 230.40 exception 5, to see if either one of these sections would be needed to regulate your installation where you had more than 6 disconnects. And then again, along with 230.70, 230.71, and 230.72, review those along with your note 3. You get a good feel for the purpose of change, and then you have the call-outs to help you understand why this new section has been added, and the information and requirements in that section need to be reviewed. So again, if you're dealing with a inadvertent transfer switch, make sure that you review all of these changes that take place in Article 705, especially 705.12, and be sure that one of the changes that took place for any section does not have any kind of impact on your design or your installation or your inspection of this type of a system.